Sorry, sorry, I muted. Thank you, Emma, and thank you, class. I muted myself in the tablet. I didn't know. All right, so let me repeat. I'm sorry, class. If I have f plus g of x, then I can rewrite it f of x plus g of x, right? And then same thing with the difference. F minus g of x equal to f of x minus g of x. Again, if you look at this, it looks like the x being distributed into the f and the g, but it is not. It's combining function. You're not distributing anything. You're combining the g with the f. For the product, same thing. For the quotient, all you have to watch out for is as long as g of x is not equal to 0, we're okay. So these four is called combining the functions. So you have two, you combine them into one. It is different with composite function. Now let's talk about the domain. What happened when I combine two functions? What if those two functions are different things? Right? Well, if two functions are different and then you combine them, then the domain of the final function will be the intersection of the domains of those two functions. What does that mean, intersection? All right, let me give you an example. What does it mean to say intersection? Say if I have, say for example, the domain of function f, I call that A. Say a set A, I have number 1, 5, 2, 3. I just make up some number here. And then set B, or domain of function G, or set B, I have the element 1, 0, 10, and 3. Then A intersection B, that is the notation of A intersection B. If you don't like that intersection, I'm sorry, if you don't like that notation, you can write A intersection B. But the upside down U mean A intersection B. It's the common element. So what are the common elements? 1 and 3, right? This is what intersection, right? You're gonna common ground, right? Say you and your friend want to go to watch a movie. You have a list of movies you want to watch. Your friend have a list of movies you want to watch. Well, you want to watch it together. You have a common ground, right? Pick a movie you both want to watch, right? So it's kind of like intersection. So here will be 1 and 3. Can other people hear me? Maybe you want to, thank you. Maybe you want to log out and log in again. Thank you, everybody. They're better than you. You're so quiet. Such a lively class. That's good. All right. Now, so the domain of the two combining function will be intersection of the two functions. So far, so good. And it's applied for the first 4. Well, it's applied for the first 3. The last one, the quotient one, there's a little bit extra. The domain of the quotient will be the intersection of the two functions, and what? And the denominator cannot be 0, right? So it has a little extra bit to it. So the quotient has a little extra bit because of the denominator. So that's okay. We'll go into the example. Don't worry. So let's take a look at number 1 example. I have f of x. It's the polynomial, yes. Right, it's a polynomial. What is the domain of the polynomial? Everything, right? Polynomial is a very smooth function. You put your hand in the graph, you can just trace it forever without being cut in the finger, right? So it's a very smooth function. In calculus, we call that continuous. And I have g of x, a bit more picky. It's only take what value? Yeah, either positive or at least 0, right? I'm talking about real number, right? I'm talking about imaginary number. So I have one function that take everything. Let me demonstrate it with the number line. One function that take everything. The other function is I have to set x minus 2 at least 0, meaning greater or equal to 0, and then solve for 2. So x had to be at least 2. So one function is the blue function, it take everything on the number line, but the red function is only take from 2 to infinity. So what's the intersection? What's the intersection? It's the darker shade, right? It's the darker shade. So the domain of the final function of the combining function will be from 2 to infinity. That's your final domain. That's what they meant by intersection between the two functions. The darker shade. Let's f of x equals the square root of x 1 plus x, and g of x is equal to square root of 3 minus x, phi h of x, which is the product of f of x and g of x. By the way, on the final, I'm sorry, on the exam, you'll be given this form, right? I really suggest you rewrite it. I really suggest you rewrite it as what? F of x times g of x. It's just more friendly looking, isn't it? As opposed to the one I highlight in green, a bit more abstract. All right, all you do is just multiply two functions together. You highlight the f is the blue, and the g is the red. So h of x is equal to f of x times g of x. Just rewriting that. F of x is square root of 1 plus x, and then g of x is square root of 3 minus x. And don't stop. Then one more step. Don't write this down. Recall, if I have square root of 2 times square root of 3, can I multiply the radicand together? When I say radicand, I mean the number under the radical, which is square root of 2 times 3, which is square root of 6, right? Now, if I have square root of 2 plus square root of 3, can I combine them together? No, right? Ever. Subtract or minus, you don't combine them. So here, I can rewrite as what? Square root of 1 plus x times 3 minus x. For me, this is good enough. I'll take this answer. You don't have to factor it out, is what I meant. But if you wanna FOIL it out, you can. So, alternative answer will be 1 time negative, say 1 time negative. So 3, I have 3 first. So 3 negative x positive 3x. So plus 2x and negative x squared. Either or. All right. What is the domain? Let's talk about domain. Well, let's talk about individual domain first. So the domain of f of x, let me rewrite f of x, which is 1 plus x. That's imply 1 plus x had to be at least 0, right? And then you solve for x. So x is greater or equal to -1. And then you go to the domain of G. Square root of 3 minus x. That's imply 3 minus x has to be also at least 0. If I add x both sides, x is less than or equal to 3. Does it bother you? I can add both sides. I can in the inequality, I can add a variable to both sides, but I cannot divide variable to both sides or multiply variable to both sides. Why? Let me give you an example. Don't write this down. Say if I have x minus 1 greater or equal to, less than or equal to 2x, I can subtract x both sides like that. And that's canceled. And I have -1 less than or equal to x. Now, this is not the true for the multiplication or division case. So for example, if I have 3x less than or equal to x times 1 minus y, something like that. And you're very, very tempted to reduce your inequality by divide both sides by x. Like, oh, that's cancel, great. Nothing wrong so far. But why is it wrong? Why is it you can't divide or multiply both sides by a variable for inequality? When you multiply both sides or divide both sides by a negative number, what do you have to do to the inequality? You flip it. Do you know x negative or positive? No, right? So that's why we don't ever do it with the inequality. Equation is okay, but you don't have to flip anything. Just the FYI. So I hope you don't do that on the Zoom. All right, let's draw a number line. Maybe that helps. I'm gonna put down two numbers, so -1 and 3. Doesn't matter the scale as long as you put the right number in the right order. Is -1 and 3 included? Yes, right, so solid dot. X is greater or equal to -1, meaning from -1, drag it to the right. So I'm taking everything from -1 to the right of it. And x is less than or equal to 3. So from 3, going the other way. What is my intersection? Yes. See, if you're in doubt, draw it out. So negative bracket -1, because you include -1, comma 3, bracket. Any question? People in the people from Zoom, you can ask question by speaking up or put the question in the chat. Okay. All right, one more. This one is the division, the quotient one. That's my f of x and that's my g of x. They both polynomial. So that's a good news. This is don't mean everything, right? I want my h of x equal to f of x. Well, let me write like this: f divided by g of x, right? And then I would, if I was you, I would rewrite it as f of x divided by g of x. F of x is 9x squared minus 4. And g of x is 3x plus 2. Am I done or I can move on? Am I done or I can do more? Should do more. I can do more, right? I can do more. 9x squared, I can rewrite it as what? Let's do slowly. Can I do it 3x, all of that square? Minus 2 square, is that okay? Do you guys remember a squared minus b squared, which is equal to? Let's finish the top. It's equal to a plus b, which is 3x plus 2 times a minus b, which is 3x minus 2. And just copy the denominator over. I can cancel something. Well, last time we called those our what? What do we call those? Huh? Discontinuity, right? Removable discontinuity. Right? But I'll tell you why we don't call that in this case. So that's your final answer. Can someone tell me what is my domain? Everything. But you sure everything? Now, you're not wrong because I didn't tell you this. Last time I taught you what? When you look at the domain or the rational function, you look at the reduced function, yes? Because last time it was one function to start with, right? How many functions I'm start here? 2. So that case does not apply here, right? So for combining function, you're gonna look at the original rational expression, right? So you look at this, you look at this one. The very first one for combining function. Because why? Because you're starting with 2 functions, right? As in previous class, we start with 1 function. Here we have 2 people liking 2 different things. So you have to take that into account. So x hat cannot be what? So looking at the original function. Oops. Let me take a little note here. For domain of f divided by g, you look at the original rational expression. No, it's not. It's neat. It's Sarah's, but it's a lot of side notes. I like to remind myself of things so I don't forget. So that means what? 3x plus 2 cannot be equal to 0. Yes. So that means 3x cannot be equal to -2, or x cannot be equal to -2/3. If you were to write it in interval notation, how would you write it? Maybe it helps if you draw it out. So here, -2/3. I cannot take it, so I'm gonna do a hollow circle. Everything but that, right? So everything, I'm going from left to right, everything, and then I skip the -2/3 and then move on. So my final domain will be -infinity to -2/3, parenthesis at -2/3, because we're not including -2/3, union -2/3 to infinity. Any question, please ask. Don't feel shy. Yes. No, you cannot do that because of plus. Now let me give you an example. Don't write this down. If I have 2, I say I have 4 plus x over 2, a lot of people are tempted to cancel that out. You cannot do that. Right? You cannot do that. So you can't do it because it's a row? Yeah, because 4 being attached to the x. Okay. You can do this. Say if I have 2 x plus 4 divided by 2. You can factor out the 2. So on the top will be 2 times quantity of x plus 2 over 2. Now you can cancel the 2. And because the 2 being what? Being multiplied. So these are multiplication, right? Multiply, multiply. Yeah. A lot of time people tempted to cancel the 2 like that, which is wrong. And I hope I don't want to see that before pre-calc students. All right, so that's combining function by what? By adding, subtracting, multiplying, and dividing. Right? Now we're going to talk about composition of function. Now you're going to put one function inside another function. The composite function of f with g is denoted by f composite g. The little hollow circle means composite. It's not multiplication. Multiplication is a little solid dot. So you read this. You read this as f composite g. Composite. Can't write composite g. And it's defined like this. Notation wise, it looks like this. F little circle G parenthesis and then of X. Again, that's not multiplication. That little X right there, that's not multiplication. X is the input of F and of G. Well, in this case of F, of G first, right? And then G of X is the input of F. So that's okay. On the exam, of course, they're gonna give you this form, the abstract form. I would really recommend you rewrite it in this form. So the letter that be next to the x will be your inside function, right? And then the one that further away from x will be your outside function. Let me explain it to you. What do they mean by domain of f of g of x is all the number of x in the domain of g for which g of x is the domain of f. It's quite a mouthful. That's what they meant by this. I have two functions. Function f, I already know in blue ball, and then function g in red ball. We call that machine, right? So this is my f, and this is my g. I'm gonna, f have input of x. So I'm gonna put x into f. What does it spit out? That's true. Spit out f of x, right? Spit out f of x. Right? Whatever you put in for the f, it spit out, that's your output. So it spit out f of x. If x is 2, f of 2, x is 3, f of 3, etc. And then once I have f of x, I'm gonna put it into function g. So now you know what they mean by g of x is the input, is the domain of f. Right? That's the input of oh, I did it backward. I'm sorry, I did it backward. I should have G first. They do G first. Here, I'll fix it so you're not confused. So let's see, blue is G and then red is F. So now I have G of X. It's the same thing, it just, I don't want you to confuse notation wise. So in the beginning, X is the input for G, and then the output will be G of X, and that output becomes the input of F, right? Because I'm gonna put G of X inside F. I'm gonna put G of X inside F. And then what does it spit out? F of G of X. Oh, F of G of X. So G of X is the input for F. Right now, it no longer just a number, it's the whole function. That's what they meant by a function inside another function. All right, let's do this work and I'll show you how to do the domain. For A, I want to evaluate G composite f of x if I was you, I'll rewrite this. I'll rewrite, so which one is the outside function? G, right? Because G far away from X. So G and then big parenthesis, and then the inside function will be f of X. So my first step, I'm gonna do from inside out, right? Inside out. So G inside, I'm gonna replace f of X with the actual function f of X. So replace f of X with 3x squared minus ax plus 2. So once again, so all I'm doing is really mechanical, really. If you don't want to think, you don't have to think. Just follow the step. Now what I'm going to do, what is the input of G now? The input of G now, I call this a blob. That's my new blob, right? No longer X, that is a blob. I'm gonna put that blob, I'm gonna replace that blob with X. So instead of X plus 3, it's gonna be blob plus 3. Right? So it's gonna be something plus 3. And that something will be the new blob, which is the new input right there, 3x squared minus ax plus 2. Now you can combine the like term, 3x squared minus ax plus 5. And there you go, you have f, g of f of x. Now the domain. Do some. There's a little step to tell you how to find the domain right here. Right here. How to find the domain of the compose function or composite function. First, set up the compose function, which we did. That's the compose function in red box right there. Now you're gonna find the restriction on the domain of the input function. The input function is, they meant the f of x, right? The inside function. So what's the domain of f of x? It's a polynomial, so everything, right? So everything, negative infinity to positive infinity. Domain of g of x also a polynomial, right? So the domain will be everything. And then because you highlight everything on the number line, you highlight everything for the first function and highlight everything for the second function. So the shaded part will be everything, right? So your domain in the final domain will be everything. And that's because you highlight everything. So that's easy one. That's easy one. For B, that's you try one. By the way, this is for my class. I think for Nicole class, she have a plan for you. And you have to contact her for that, okay? Number 5. Given f of x, looking like that, and then g of x, looking like that. I want to find the domain of the composite function g composite, f composite g of x. I don't feel like going through that because you already know. Yeah, number 5, you can read it. I don't want to go through that. Oh, we can do number 6. It's the same thing. I can walk through the step. Same thing as number 6. do number 6. So step number 1, I'm just rewriting the step here. Set up the composite function or compose, whichever way you would like to say it, the composite function. Let's do that. So so they want f composite g of x like that, right? And we would rewrite it as the outside function will be the f, right? And the inside function is g. And now I'm going to plug in g into f. So g is, instead of g of x, it's going to be square root of ax plus 16. So far, it's just mechanical input. There's no brainer there. I'm just plugging things. Now, what I'm going to do with f, instead of x, I'm going to replace x with, with that block, right? With that big thing. Right? So I would recommend you do this. For the f function, everywhere you see x, replace with the big parenthesis. Right? So 2 times block, which is parenthesis here, minus 10. And that block will be square root of ax plus 16. I mean, that's it. Nothing you can do more. Nothing you can do more. Done. There's no simplification that you can do. So done. What is the domain? Remember, find the domain. You find the domain of f, right? So domain. So step number 2. Maybe write step number 2 over here. Step number 2, you find the domain of f. Let's find the domain of g because g is inside, right? Let's find the domain of inside function first. So domain of g of x. What does that mean to be the domain of g of x? It's the square root function. So everything under square root has to be at least 0. So that's imply ax plus 16 greater or equal to 0. Subtract 16 both sides, ax greater or equal to negative 16. Divide both sides by 8, x is greater or equal to negative 2. And then you find the domain of f. I'm sorry, yes, of f. That's right, domain of f. Of f of g of x. Now the domain of f of g of x. Right. What f of g of x? That one we box in blue. So that means everything under the in the denominator cannot be 0. Right. So that means 2 times square root of ax plus 16 minus 10 cannot be 0. But let's set it to equal to 0 for now. Just let it set equal to 0 for now. Go up here. Can I add 10 both sides? 2 square root of ax plus 16 equal 10. Divide both sides by 2. You're going to isolate the square root. Do you know how to do that? Isolate the square root. Let's cancel. So you have square root of ax plus 16 equal 5. What do I do next? Square, right? Square. Both sides. On the left hand side, square and square root cancel because they inverse. So ax plus 16 equal 5. Now it's linear. Everybody should be able to solve for this. Ax equal 9. X equal 9 over 8. We're not done. Right? We're not done yet. We're going to put them in number line, on number line. Oh, by the way, you say x cannot be equal to 9, 8, right? Forgot about that part. I know we set it equal so we can solve for x, but at the end, we put a little slash over it. Negative infinity, positive infinity. Negative 2 come first, so because it's negative. And then 9, 8. Do I include negative 2? Yeah, so solid. Do I include 9, 8? No, so hollow. So one step at a time. For this class, everything is like that. You do one little thing at a time. Now, for the first function, for the red one, x has to be at least negative 2. So that means from negative 2, drag it to the right. But you have to skip that little hollow dot. Sorry about that. And then for the blue function, it say everything but 9, 8. So what is your shaded area? Yeah, so the darker shade will be from negative 2 bracket, because you include negative 2, to 9, 8, right? Because we have to skip the 9, 8. Parenthesis union 9, 8 to infinity. Do you have any questions? Now is a good time to ask. I'm pretty sure something like this will pop up in the exams. It's pretty important. It's helpful if you pay attention to the lecture as well. All right. Apply problems. Apply problems. Now you ask me, where do I view this in real life? You actually use it a lot more than you realize. You actually use math every day. You just don't really pay attention to it. So let me show you where one of the circumstances you use composite function. Say you have a $50 coupon from the manufacturers that is good for purchase a phone. So you want to buy a new iPhone, you got a coupon for $50 off. The store where you put the purchase your phone is also offering another 20% discount on all phones. Let's represent the regular price of the phone before any discount at all. Now, scenario 1. Suppose only 20% discount applies, so they don't let you combine the coupons. Sometimes they do that. They will say only 20% discount applies. So what does that mean? Find a function f that models the purchase price of the phone as a function of the regular price x. So let's find f of x first. If you're allowed to use a 20% coupon, so what is the price of your phone now? the regular price X. So what's the price that you're paying? That's 20% discount. So you pay the remainder, which is 80%, right? Of the regular price. 80% of the regular price will be, well, 80% is 0.8 of mean multiply the regular price X. 0.8X. Like I said, you use math every day. You just don't think it in this way, right? Most people just think, oh, I know if the phone is a phone $1,000, I'll pay 800, right? They think it like that. They're very quick, but they don't actually put it in math form. It's called common sense. All right, part B. Suppose only $50 coupon applies. What is my new function now? Let me call that G. Huh? X minus 50, right? Whatever the phone cost is, subtract from 50. So that's okay. Now, part C, they allow you to use 2 coupons. But which one you use first? Maybe which one to benefit you? Should I use the 20% first and then $50 coupon? Or should I use the $50 discount first and then 20%? So see which one benefit you more. So let's see. So the first one say when making the purchase, the coupon may apply first, followed by the coupon. I'm sorry, followed by the discount. Coupon apply first means the inside function will be your coupon function, right? So coupon function is the red one. Let me highlight it. So coupon is the red and the discount is the blue. Because the coupon apply first, that will be your inside function. So G of X. And then the outside function will be your F. That's how math people write it, from English to math. G of X, now you do what you normally do. You put G of X inside F of X. G of X is X minus 50. I'm sorry, X minus 50. And now you're gonna plug X minus 50 into your function F, right? So equal, the function F is 0.8 times blob. And that blob now is X minus 50. And then I'm going to distribute this out, which is, let me put it horizontal like that. So equal 0.8x minus 0.8 times 50 is 40. Yeah, 40. Thank you, 40. Use it black. All right. So that's when you use the coupon first and then the discount. What about the other way around? What if you use the discount first and follow by coupon? So discount first means that's your inside function. Discount is the blue function. And then the coupon is the outside function. F of X is 0.8x. And now you're going to plug that 0.8x into the G. So the G is blob minus 50. And the blob will be 0.8x. And then your final answer will be 0.8x minus 50. Which one you want to use? The second option, right? You want to apply the discount first and then the coupon. So let me recap for composite. Let me recap. For combining function, let me go all the way back here. For combining function, you combine them using those rules, which is very straightforward. Right? How do I find the domain of combining function? Well, you find the domain of the first and you find the domain of the second, and then you draw on the number line and see where they intersect. That's your combining domain. Right? Composite function is slightly different, actually a whole lot different. For composite function, you put one function inside another function. Right? It still start out with two, but just the way you operate them a little bit different. You just shove one into another. How do I find the domain of composite function? I find the domain of the input function, the one inside, and then I find the domain of the composite function, the very final one that you had, right? And then the last step will be the same thing as the combining function. You draw a number line, and you see where they intersect. So the only thing different finding domain between combining function and composite function is the step two. Step two is different, right? I know you can do it, but it's just like on the exams with so many things together, you forgot. I understand. I feel the same thing when I take the exam. That's why you gotta study well. I know you know how to do it if you look at my note and you do your homework, but it's a different story when it comes to exams. It's more like mental things. Some people just cope with stress better than others. All right, objective 4, evaluating the composite function. So far, all I give you is x. I don't give you a specific values. Now we're gonna do that. It's the same thing, but a little bit better because you can evaluate your function. Given f is a polynomial like that, and g is a rational expression like that, or rational function, I want to find f composite g of 3 against, what is my outside function? F, right? So f will be outside and g will be inside. And now the input is no longer x, is 3. Right? Same thing, you do one step at a time. So let's write the outside function so we don't forget. What is g of 3? Very good, very good. So I'm glad you say out loud. It helped, really. So 36 over 12 minus 3. Everybody know how to do that? 4. So g of 3 is 4. And now you're going to plug in that 4 for f. You like this better or the X one? This one better because it's human. We're not good with abstracting stuff. Right? We very visualize. That's how we evolve. Visualize. So people like number better than letter. Number 9 is that your you try? Yeah, your you try. So that's one way of evaluating the composite function. I can give you another way as well. So that's by algebra. We can evaluate by table. So the second method, we evaluate the composite function by table. 10a, I want to evaluate f. I already know f is, let's say f is blue and then g is red. Make that consistent. So this, I want to, if I were to rewrite it, it would be f is outside function and g is the inside function. And then you always do from inside out, from inside out. What g of 3, if you look at the table, what g of 3? 2, right? And you plug it in there. So f of now is instead of g of 3 is going to be f of 2. And then you look at the table, what's f2? 8. Done. Take a moment and I want you to do B on your own and tell me what you got. People, my Zoomer, you can put your answer in the chat. We'll talk about 10B. Record. All right, what you got have? 2? Is that what you got, 2? Yeah, all right, let's check it out. G is the outside function, and then F is the inside. F of 3 is 3, and then G of 3 is 2. Right, C, it's just longer, it's the same thing, right? So the outside function, well, let's do the inside function. The inside function will be F of 6, right? And then what else? And then the G covering it, and then one more, it's F again. Got layers, that's all. What F of 6? 6 is 4. What G of 4? 7. All right. And then F of 7? F of 7? No, right? So we would say does not exist. D and E. Almost done. Now the third way is using the graph. So we use algebra, use table, and now the graph. G composite F of 1. What F of 1? 1, right? F of 1 is 1. And then G of 1. G of 1 is 3, right? So you guys get the idea, yeah? I'll let you do B on your own, C on your own. Let's do D together. Oh, no, you try. Just do at home. If you try, I'll write in purple. I always do. G composite G of 1. What G of 1? 3. What G of 3? 4. Not too bad. Ooh. Oh, that's H. Okay. E. E. What's H of negative 1? H of negative 1, 1. Right. So let me write like that. So equal G of F of H of negative 1. There's a lot of color. So G of F. So H of negative 1 is 1. You say 1. And now you plug in 1 for F. What f of 1? 1. G of 1. 3. So you get the idea, right? Not too bad. You do yourself, not too hard. Actually, let me, because I'm not gonna do this, but write this for me. Can somebody write this for me? This one in your notation. So inside will be, yeah, h of -2, and then what's next? Yeah, and then yeah. Okay, I'm not gonna do it, but just practicing how you to rewrite it. Number 12, last one, and we'll call it a day. Okay, now is reverse engineering. I tell you what F is, and I'll tell you what G is, and then I ask you to do F composite G. But now reverse, I tell you what is the composite function is, you give me the original functions. There are more than one way to do this, but I'll tell you what the easiest way, that's at least in my case. So this is asking you to find F of G. Well, you find F and G, right? I'll just rewrite that. When you see these kind of problems, the easiest way is to find the outside function first. So the outside function is something to the 50, right? So blob to the 50, right? So I'll tell you if it makes sense when you see me write down. So I'm gonna let f of x equal x to the 50, and guess what? I'm gonna let g equal to. Huh? Well, what should g be when I plug it in? It's gonna be blob to the 50. X squared plus 1, right? X squared plus 1. Does that make sense to you? Yeah, when you plug in g into f here, so blob to the 50, and that blob is the red one, which is h of x. So it's easy to do outside function first. Now, some student can do this. And it's right, it's correct. So they let f of x be x plus 1 to the 50. Who would thought of that? What do you think I'm gonna let g equal to? When I plug in, I should have x squared plus 1 to the 50. X squared, x squared. Which one? Does that make sense to you? When you plug in the blob into f, blob plus 1 to the 50, right? X squared plus 1 to the 50. Which one you like better? For me, it's easier this way. Well, which one is right? They both right. They both right. It's a different way of doing things. For me, I prefer this. I like to do the outside function first. I always let the outside function equal x to the whatever, right? If it's like square root, it'll be square root of x, and then I'll let g be the what underneath it. Does it make sense? Or inside it? Practice one more, and then we'll go. So again, this is, I want f of g of x again. What f should be? What f should be? Think of it, x minus 2 is a blob. Square of x, right? And then now g will be what? X minus 2, right? So when you plug in the x minus 2, you have square root of x minus 2. Practice more, you get.